Hello, my name is Claire Kim. I will be doing the teach one for the Charleson accuracy assignment. Everything that comes from these slides can be found in the assignments for accuracy in the webpage link. And they should be able, you can visit that site for more information as well. The first thing you'll have to know and understand is sensitivity. Sensitivity you can find by dividing the true positives divided by the true condition present. And true positives are when it predicts that the condition will occur, and it does indeed end up occurring. A false negative actually is an error in the prediction and also the absence of the condition. The higher the sensitivity, the more accurate the prediction is of the presence of the condition. The next one is specificity. It's the same idea, however specificity is the true negatives over the cutoff periods divided by the true condition absent. The higher the specificity, the more accurate it is in predicting the absence of the condition, and having a high specificity means that they do not often mistake other things for the condition. So finally, you'll have to find the area under the curve using the cutoff points. Straight dotted line actually would show what would happen if you were to predict the changes randomly. The changes in cutoff points also show the changes that lead to different levels of sensitivity and specificity. And so using these cutoff points, you'll have to find the area under the curve to show us how the prediction of sensitivity and specificity is more accurate than a random prediction. So now I'll be showing the actual SQL code to be able to find these numbers. So the first thing you'll have to do before you start is refer to the first assignment. You have to make sure that your clean table is correct and that you come with an output of 1,741,402 patients subject to analysis. This is very important to finding the correct area under the curve because it will affect your code. Next, you'll have to refer to the scoring assignment. This is the assignment that you did last week. You'll have to keep everything, make any edits if you have to. Make sure that the numbers and outputs come out just like the ones in green in this code. Again, it is crucial that you come with the same numbers. So the first step will be to set a range of cutoff values ranging from 0 to 1. These are the rows that you'll need for the area under the curve. Then you'll have to order the data in terms of predicted value and calculate a row number for each value. And this is shown here on the code on the left. And you should again get the results in green as well. So next you'll have to compare the predicted scores to the cutoff values. That's shown here on the left through this code. Here you'll have to select the cutoff, use the if statement. If the predicted is greater than the cutoff and with the values 1 and 0, then you store it as predicted, and then you'll have to store it into a temporary table. And the next step is to calculate the sensitivity and specificity rates. To do this, you have to remember that sensitivity equals the true positives divided by the true condition present, and specificity is the true negatives divided by the true condition absent. And this will be shown here on the left through this code as well. So after running select from senspec, which is the last select code in the SQL, it should provide you with an output of this chart. And what you'll actually have to do is copy this whole thing with the headers and put it into an Excel worksheet shown in the next slide. So here the table is added into the Excel worksheet, and you'll actually have to add an additional column which will be 1 minus specificity, and you'll actually have to type in the equation equals 1 minus everything that's in column specificity, and just drag it down so that the whole column gets the equation. And the Excel table should look something like this, and then you can actually copy and paste the sensitivity and the 1 minus specificity together. It'll just be easier to graph your charts later in the next slide. So here you can see that the two columns used were the sensitivities. These were both used to create the gray line going through the middle. This is the line that predicts what would happen if you were to make the changes completely randomly. And so you'll actually have to make this chart and copy it and paste it into your other chart for the sensitivity over 1 minus specificity. So this is the sensitivity over 1 minus specificity. Just graph these two columns to be able to get your predicted scatter plot. You can change you'll have to use the scatter plot and attach the lines, and you can change the colors to however you'd like, and even the size of the markers. So lastly, you'll be finding the area under the curve using this code right here. You should get the final answer to be 0.06179, etc. That is the correct answer you should be getting. The closer the area under the curve is to 1, the more accurate it is. So in this case, it is closer to 1, therefore it is accurate. And that concludes my Teach 1. Thank you.